Okay, number one, explain what it means to solve a quadratic equation. So again, this just means that you're finding two numbers so that when you plug them in, either the equation is true or the output is zero. So you're finding two numbers that when you plug them in, these are input numbers, right? So when plugged in, make the original equation true. Or they make the output zero, or make the output zero. So just like to give you some examples, right? So if we scroll down and look at some of these right here, if I ask you to solve this equation right here, it's already set equal to zero. And so basically you're just looking what numbers for x would actually make this part right here equal zero. Okay? If you just had this function but it wasn't equal to zero, you would set it equal to zero and try to figure out the numbers for x that make it equal to zero there. Okay, so that's what it means to solve. Let's actually do number 2 here. So we're going to solve by factoring. And remember, factoring is where we're going to break this apart into its factors, the things that when multiplied give you the result. So the question is, what two things would we need to multiply to get x squared minus 3x minus 10? And we know it's got to be x and x. And the idea here on this is, since you have an x squared here, you're looking for two numbers that when we put them in here are going to multiply to give us negative 10, but would also add or subtract to give us negative 3. And so a lot of times what I'll do on these is I will look for numbers that when I multiply them I get 10. I know it's got to be negative 10, but I'm just thinking like, okay, 10. So that's either going to be 1 and 10, 2 and 5, 3 doesn't go into 10, 4 doesn't go into 10, 5 we already got there. The nice thing is once you reach the halfway point to a number, you don't have to look to see if a number goes into it, right? Like it's pretty obvious 6 is not going to go into 10 because if you double 6, it'll give you more than 10. So 7, 8, and 9 also aren't going to go into 10 for the same reason. Okay, so we've got these potential combos, right? So maybe it's 1 and 10 here, 1 and 10, 10 and 1, or maybe it's 2 and 5. But basically the idea here is you're looking for whatever numbers you pick, we got to get to negative 3. So between these two, how are we going to get to negative 3? Well, I would say 5 and 2 can get us to negative 3. How are they going to get us there? We need to subtract 5. We need to add 2. So if you actually go through and multiply this out, what would you get? You'd get x squared, and then you would do x times 2, so that would give you plus 2x, and then you'd get negative 5 times x, so that's negative 5x, and then you would do negative 5 times 2, which would give you negative 10. And if you write this out, what do you get? You get x squared. That's a weird x. So x squared, and then what do we get here between the plus 2x and the minus 5x? That would give you negative 3x minus 10. So this is just, you don't have to write out what I just wrote out here. This is just me checking to make sure that it actually works, right? So what we're going to do is we're going to go back on this, and we know we have factored it correctly. So now what we need to do is actually solve. A lot of you missed points on this because you factored correctly, like you wrote this down, which is great, but you didn't solve, which brings us back to what does it mean to solve, right? Oh, those things are moving. That's kind of weird. What does it mean to solve? It means that you're looking for two numbers that when you plug them in for x, they're going to actually make this equation, or this equation, because they're the same thing, equal 0. So what could I plug in for x that would actually make this equal 0? Well, there's a pretty quick way to find out. If you let each factor here, so this is a factor, this is a factor, if you let each factor actually equal 0, it'll tell you pretty quickly what x would need to be. So in this case, x would have to be 5, right? So if we add 5 to both sides, you get x is 5. On this one, if you subtract 2 from both sides, you'll get x is negative 2. Okay, so those would be your two solutions there. Actually, let's go back here. So we'll say x, our actual answer is going to be x is negative 2 comma 5. We'll put those curly brackets on it. That would be our final solution for that. All right, number 3. So same idea. So we're going to solve by factoring. And on this one's a little harder because you've got a 2x squared out in front. So what I'd like to do on these is I'll go ahead and write the parentheses here. And I know I've got a 2x and an x here. So when I multiply those two together, I know I'm going to get 2x squared. Now the question is, what numbers multiply to make negative 20? Unfortunately, on the last problem, we were able to ask about, hey, what numbers get us to negative 3, right? We went over and we had negative 3 there. But the annoying thing about this one is the two numbers that we pick, because there's a 2x squared here, I can only guarantee that these two numbers are going to multiply to be negative 20. I can't guarantee that they're going to add to be negative 3. And in fact, usually when there's a number out in front of the x squared, something other than 1, they actually don't add up to be negative 3. So what we got to do is we got to play around with different combos here. And probably the easiest way to do this is I'm going to come over and I'm just going to write down some different combinations here. So we've got 2 and 1. That comes from here. This is the 2x and the 1x. So you can kind of think of it like this, 2x and 1x. Let's write down some different pairs of numbers here that could multiply to get us to negative 20. So you could have 1 and 20, and I'm going to actually organize these by color here. So you got 1 and 20, you've got 2 and 10, you've got 3, doesn't go into 24 and 5. And the goal here, I think that's it, right? 6, 7, 8, 9, don't go into 20. We've already got 10, and once we get to 10, we're already halfway, so we don't have to check anything after 10. Okay, so what I'm going to do is I'm going to look for like pairs here, like 2x with 1 and 1x with 20. If I do this, what do I get? I get 2x and 20x here. Is that going to be able to get me to negative 3x if I add or subtract any combo with this? And the answer is no, right? If you add these, you get 22. If you subtract them, you get 18x, right? So I know that if I pair 2x with 1 and I pair 1x with 20, that there's no way that that can get me where I want to go. So let's go back and undo that. And let's try maybe another combo, right? So you could do 2x with 20 and 1x with 1. That would get you 1x. And let's see, 2x with 20 would give you 40x. Again, same question. If I have 40x and 1x, is there any way I could get to like negative 3x? And the answer is no, no way. So it looks like 1 and 20 are out. Like they're just not going to work. How about 2 and 10? So if I pair up here and here, what do I get? I get 4x and 10x, right? If I do 2x times 2 and 1x times 10. So 4x and 10x, that's not going to work. What if I do 1x with 2 and 2x with 10? That'll give me 20x on here, and then that'll give me 2x here. 20x and 2x, no way I'm getting to negative 3x. It looks like 2 and 10 are out. What if we, I'm going to move this around here. Oh, shoot, that's not what I wanted to do. What if we pair up down here? So what if we do 2x with 4 and 1x with 5? So 2x with 4 would give us 8x, and 1x with 5 would give us 5x. That could get us to negative 3x, right? Like if you have 8x and 5x, you would need a negative 8x, right? To get to negative 3x. Okay, so if the 8x is going to be negative, that means we're going to have to toss in a negative here on the 4 to get us to negative 8x. So, okay, so we figured out the combo here. What do we need to do? We need 2x to multiply negative 4. Be really careful here. Some people try to put it right here, but if you put negative 4 here, 2x is not going to multiply with it. It's just going to subtract right there. To get the 2x to multiply with the negative 4, you actually need to throw it over here. So let's do that. We'll put a minus 4 here, and then we'll put a plus 5 here. And I'm just going to check this real quick. Like if you actually multiply this out, what do you get? You get 2x squared, and then you get 2x times negative 4 gives you negative 8x. You get 5 times x, so plus 5x. And then you get 5 times negative 4, which gives you minus 20. So what is this? 2x squared How many x's do we have here? Negative 3x minus 20. The question is, does this match what we started with here? And the answer is yes, it does. So that means we factored this correctly. Okay, cool. So I'm going to erase all this stuff here. All right, so have we finished the problem here? It says solve by factoring. We have factored, but we have not solved, right? So we need to figure out numbers for x that make this true. Now, some of you just went down here and wrote 4 and negative 5, and you lost points for that. Why is that? Well, if you plug in 4 for x, it will work, okay? If you do x minus 4 is equal to 0, you'll get, you'll add 4 to both sides. You'll get x is 4. That's one of the solutions. However, if you plug in negative 5 for x, you will not get 0. If you don't believe me, go up here and plug in negative 5 and multiply it out. It's not 0. Why is that? Well, because you don't want x to be negative 5. You want 2x plus 5. You want that whole thing to be 0. So set the whole thing equal to 0 and then solve. Okay, so 2x plus 5 is equal to 0. We're going to subtract 5 from both sides. And then we get 2x is equal to negative 5. And then if we divide by 2, we get x is negative 5 halves, right? Negative 5 over 2. So what's our solution here? Our solution here is x is negative 5 halves and 4. Both of those work. All right, number 4 wants us to solve by completing the square. So what I would recommend is to draw the scenario that matches the equation over here. So we got an x and an x. And we've got an 8x here. And so you'll remember what we did on these was we tacked on a little rectangle here to both the top and the side. And we figured out, okay, if this is x squared, because, you know, x times x is x squared. And if this side here is x, because this is x, and therefore this is x, and then therefore this is x, we're going to need 4x in this square. So we're going to take the rectangle there, whose area is 4x. This rectangle's area is 4x. And that means that these right here must be 4. So like this blue distance here needs to be 4. This blue distance also going to be 4. Then what happens here is if you actually add on this little square here, this little box, it will complete the square. And so the question is, what's the area of that little square there? Well, if this is 4 and this is 4, then that little square there is 16. And so what we're going to do is we're going to add 16 to both sides. By adding 16, it literally completes the square. So what we'll have here is on the left, we'll have x squared plus 8x plus 16. And that's equal to 33 plus 16 is just 49. So what you'll find here is that all this added together is actually just 49. This box right here is 49. But more importantly, and this is kind of fascinating, right? This x squared plus 8x plus 16 actually breaks down into a really nice square. It's just something squared. And the question is, let's actually take the 49 out for a sec, just so we can focus on this. If you have x squared plus 8x plus 16, it's a nice square. The question is, what are the sides of the square that get you that? Well, and all you have to do is look at it and see, like this orange side right here, what is the length of that orange side of the square? It's the same as this one, and it's x plus 4. So what we do here is we go down and we say, quite literally, that this is just x plus 4. That's what that side length is. And if you square that, you get 49. So if x plus 4 squared is 49, then what we can do is we can take the square root on both sides, and by taking the square root, it basically undoes the effect of the square there. Don't forget, when you take the square root, you got to do plus or minus there, because it could be positive or negative. Okay, so when you do this on the left, you just get x plus 4, and then on the right, you end up with plus or minus 7. And then from here, we're just solving, right? So we just subtract 4 on both sides. And remember on these, when you do this, be careful because, that's locked in. I do not want that. Anyway, you've got x is equal to, a lot of people want to say 3 here, plus or minus 3, because, 7 minus 4 is 3. But you got to be careful. What you actually have here is you have positive or negative 7, and you're subtracting 4. So there are two cases. You either have positive 7 minus 4, or you have negative 7 minus 4. In the first case, you get 3. In the next case, you get negative 11. And so that would be our two solutions here. Our two solutions are x is equal to negative 11 or positive 3. All right, number 5, solve by using the quadratic formula. So the first thing we got to do on this is figure out what the a, b, and c values are. So I'm going to label this one as a. The negative 4 here is the b. And then negative 48 here is the c value. And remember, the way these work is you line this quadratic up in standard form. So you want to get the x squared part first, and then the x part, and then the number. And basically, the a is just the coefficient, or the number that goes in front of the x squared term. So that's a. B is the number, or the coefficient in front of the x term, and then c is just that constant there. And the quadratic formula is, what it does is it finds two solutions for you. So x is either, it's negative, and then you put in b, and then you do plus or minus. So these are your two solutions. So negative b plus the square root of b squared minus 4ac, and then negative b minus the square root of b squared minus 4ac. And then we're going to divide by 2a. So we'll do 4, and then in the parentheses there we'll put a, and then c. Sorry, I got to keep changing colors here. And then c is the blue one there. And then this is all divided by 2 times a.
Daddy.
Sorry about that. My daughter was asking me a question. Okay, so what we're going to do, all we're going to do is we're going to take this formula here, and what happens here is if you plug in the a, the b, and the c, it'll give you your two solutions. So what we'll do is we'll do x must be, so we're going to do negative b, so b happens to be negative 4, and then we're going to do plus or minus the square root of b squared minus 4ac, and then we're going to divide by 2a. I'm just going to fill that out now. Okay, so b squared, so we got negative 4 in there. And then we're going to do minus 4 times a, where a was 2, and c, where c is negative 48. And then this is all going to be divided by 2a, so where that number there is 2. Okay, so we got that, and then we're just going to simplify this a little bit. So we got negative 4. So that is positive 4. Then we got plus or minus the square root of negative 4 times itself would give you positive 16. And then we're going to do minus, and typically what I'll do on these is I'll do, it kind of depends. I kind of view it as subtracting whatever 4 times 2 times negative 48 is. Some of you will take negative 4 and multiply it with 2 and negative 48. That's fine. It works the same way either way. So if you do it this way, though, what's 4 times 2 times negative 48? When you actually do that, you'll get 8 times 48, which is 384. Right? But except it'll be negative, right? So you'll have negative 384. So some of you will just turn this into plus 384. That's probably the best way to think about it. So yeah, just do that. Do negative 4 times positive 2 times negative 48. The negative times negative will give you a positive. So you'll end up with 384 there. Okay, so do that. And then we are going to divide that by 2 times 2, which is 4 on the bottom there. Okay, so now we're just simplifying. So x would be 4 plus or minus the square root of 400. So 16 plus 384 is 400. And then we're going to divide by 4. Now, some of you got points off for how you simplified this. So how do you simplify this correctly? What you need to do is you need to take the square root of 400 first before you do anything else. Some of you decided to do 4 divided by 4 and wrote 1, and then you did like 1 plus or minus the square root of 400. You can't do that, unfortunately. If you want to be able to cancel stuff like that and divide, you have to be able to do it with everything. And you can't divide inside the square root here. You can't just divide everything by 4 and just call it a day, right? You need to actually take the square root of 400 first. Okay, so let's do that. We've got x is equal to 4 plus or minus. When you actually do the square root of 400, it's 20 over 4. And so what you've got now is you've got two scenarios. You've got either 4 plus 20 over 4 or 4 minus 20 over 4. These are going to be your two solutions. So 4 plus 20 would give you 24 divided by 4, which would give you 6. When you do this, you get negative 16 over 4, which is negative 4. So those are our two solutions then. X is either going to be negative 4 or positive 6. And again, if you guys are on the retest, remember you can plug these in and make sure they work. If you actually go back in and plug them into the original equation here, you'll see that they work. All right, number 6 here. So they want to know, what is the GCF, which stands for greatest common factor of 12xy squared plus 9x squared y plus 6x cubed y cubed. The question here is, what is the largest number that we can pull out of each of these terms? And so typically what I recommend doing here is, if you just look at each term, sorry, I'm grabbing my highlighter. If you just look at each term, like we've got the 12, the 9, and the 6. So the question is, what's the largest number that we can pull out of 12, 9, and 6? Like, what's the biggest number that goes into all three of those? And I would say the answer there is 3. A lot of you tried to pull a 6 out of all three of these, but you cannot pull a 6 out of the 9 here, right? So 6, you'd have to multiply it by 1.5 to get to 9. Okay, so we've got 3 is the largest number that we can pull out of those terms. If you look here at the x for each scenario, so I'm going to highlight those in blue there, the largest thing you can pull out of this would be just x, right? There are 2 x's here and there are 3 x's here, but you cannot pull 2 x's out of this. If you divide by x squared, you're not going to have enough to be able to do that. So that's going to be x is the largest thing you can pull out there. And then if we finish this idea by looking at the y's, so if you look at y squared, y, and y cubed, the most you'd be able to pull out is just a single y there. Okay, that is actually the answer. This is it. Like, you don't need to say anything other than this. You don't need to actually factor it. Many of you factored number 6. You factored this expression, but all they were asking for is, hey, what's the GCF? What's the greatest common factor? Number 7 wants you to actually take this, and it wants you to factor it. So what you're going to do is you're going to take the greatest common factor out, right? We know it's 3xy. And then what you're going to do now is you're just going to put in what's left over for each term, right? So you have 12xy squared. When you pull a 3xy out of that and divide it out, you're going to be left with something here. Same thing here, same thing here. So let's actually do this. And like I always recommend, like, I will go in and actually write divided by 3xy, divided by 3xy, divided by 3xy, because this helps me think through, if I actually simplify this, what would I get? Okay, so 12 over 3 is 4. If you have x divided by x, that's essentially 1, so I'm not really going to bother writing anything. I mean, look, you can write times 1 there, but it doesn't really matter. Okay, and then if you have y squared divided by y, that's going to leave you with just 1y there. Okay, so that's going to be 4y for that part. And we're going to do the same process here. So 9 divided by 3 is 3. You've got x squared divided by x, that's just x. And then you've got y divided by y, which again, you could write 1 here, but that's kind of pointless, so let's just not. And then last part here, so we got 6 divided by 3, that would give you 2. You've got x cubed divided by x. That would give you x squared. And then you've got y cubed divided by y. So that'll give you y squared there. So this would be your answer for number 7. That's all they're looking for number 7. All right, so for number 8, they wanted us to graph the function with at least 5 points and fill out the table. So probably the easiest way to do this would be, well, actually, if you remember vertex form, right? So this is vertex form here. If you remember vertex form, you know that this right here is how much it takes a regular parabola, which kind of looks like this right here. Takes a regular parabola and moves it down 8. So you know it's going to move a regular parabola down 8, and then this will move it left 3. So we know instantly, like, hey, I know for sure that the vertex is going to be right here at this point. And then this 2 here just takes what would normally be a normal shaped parabola and it stretches it vertically so it gets a little skinnier. So that's essentially what I know I'm looking for. I know that the vertex is going to be right here at -3, -8, and it's going to be a little skinnier than usual. But probably the best way to do this would be either, if you guys are taking that OST state test, maybe use Desmos to graph this for you and just grab some points and you could plot it on the actual graph here. But probably the quickest, easiest way to do this would be to take your graphing calculator, go ahead and hit y equals and type this in and hit graph, and it'll graph it for you. And then if you hit second table, it'll just give you a table of XY values. So I did that. I have mine available right here. Looks to me like when I plug this in, I get 0. When I plug in, when the x value is -5, then I get -6, and then I get -8, and then I get -6. And then when I plug in 2, I get 42. And then if you scroll down on the calculator, it looks like, let's see, when I get to 17 here, it looks like the output is 792. Okay, and then if I scroll back, so this is interesting. This is saying when the output is 90, what do you have to put in to get 90? And if you scroll through your table, there are actually a couple different answers for this. It looks like 4 works, and it also looks like -10 would work. If you scroll back far enough to -10 for x, you'll get an output of 90. So you can put 4 or -10 here. Either one would work. And then typically what I recommend on these is just take the table and plot the points, right? So if -5, -5, 0 is actually a point, let's actually go over and drop a point there. So -5, 0 is a point. -4, -6 is a point. -3, -8 is a point. -2, -6 is a point. -1, I'm just looking at my table here. -1 gives me 0. And then if you do happen to plug in 0, you would get 10. So it looks like if we come up here to 10, if you plug in -6, you get 10. And so this parabola is going to look roughly like this. I guess it said you only had to have 5 points there, but whatever. So I just like to draw as many as possible. Okay, so that's all they wanted you to do for number 8. How about number 9? So number 9 wants you to factor the expression. So factoring, all we're doing here is breaking this down into figuring out what multiplies what else to give you x squared minus 36. Notice how there's no equation here? Like this is not equal to 0 or anything. And it doesn't say like f of x, so it's not saying solve the equation. It's saying factor the expression. So all we're doing is just going to figure out what we would need to multiply to be able to get this. And the trick on these is to realize, hey, this is actually x squared. This is a perfect square here. So 36 happens to be 6 times 6. So what happens on these is you've basically got x squared minus 6 squared. And the easiest way to do these is to realize that these turn into x plus 6 and x minus 6. If you don't believe me, just multiply this out and you'll actually get x squared minus 36 there. Okay, so that's that one. Number 10, which of the following is equivalent to the expression, I don't know how to read this, box squared minus 9. I don't know what to call that thing. Black square. I'm just going to call it box. So basically, this is the same as asking, hey, what's equivalent to x squared minus 9, right? Like you can plug in anything you want. You can plug in a triangle minus 9. You can plug in a pentagon minus 9. Pentagon squared minus 9. It's all the same thing. So really what we need to answer is if we look at some of these expressions down here and multiply them out, let's see what we get when we multiply them out. Okay? So I'm going to do this first one here. Box plus 3 times box minus 3. Let's just multiply all these out and see which ones actually are equivalent to box squared minus 9. So if you multiply these out, what would you get? You would get box squared minus 3 box. And the way I'm getting that is I'm taking box times negative 3, right? So I'm doing box times box first, and then I do box times negative 3. What am I going to do next? I'm going to do 3 times box. So that'll give me plus 3 box. And then the next thing I'm going to do is 3 times negative 3. So that'll give me minus 9. And if you actually simplify this, what you'll find here is that negative 3 box and plus 3 box will cancel with each other. They become 0. So you're left with box squared minus 9. Okay, so that actually is equivalent to that expression. Let's double check all the other ones and make sure none of them actually are also equivalent. Okay, so what would box minus 3 squared be? Well, that would be box minus 3 times box minus 3. And what would this be if we multiply this out? That would be box squared minus 3 box minus 3 box. And then negative 3 times negative 3 would be plus 9. So what is this actually? This would be box squared minus 6 boxes plus 9. And that is not equivalent to this. Okay, so be really careful. A lot of people are tempted to say, oh, well, wouldn't this just be box squared minus 3 squared? So that? No, it's not. You actually need to multiply it out. Take the time to do this, and you'll see that it's definitely not the same. Okay, all right, so that one's not the same. If you do box squared or box plus 3 squared, what would that be? That would be box plus 3 times box plus 3, right? So what would that be? That would be box squared plus 3 box plus 3 box plus 3 times 3 would be 9. Is that the same as what's up there? So that'd be box squared plus 6 box plus 9. No, that's not the same. So that one's out. That's out. That's out. This one works. Box minus 9 squared, what would that be? So I'm going to actually write that out in blue. So that would be box minus 9 times box minus 9. And what is that if you multiply that out? That would be box squared minus 9 box minus 9 box plus 81. Definitely not the same. How about this last one here? So if you have box minus 3 times box minus 3, just looking at option choice E here, that's actually the same as B. So we already know B doesn't work. So that's out. So apparently A is the only one of these that's actually equivalent. All right, let's look at 11 here. 11 says solve the equation. And there's not one specific set way to solve these, but there are kind of general rules on these. So the first one is that really your goal here is to get this x minus 3 squared part alone. When you get that alone, you can take the square root and then solve for x. So that's kind of our first goal here, is to get that alone. So in order to get that alone, there's a couple problems here. We've got a 2 here and we have a minus 13. As a general rule, you don't have to follow order of operations like PEMDAS. You don't have to follow that here. That only applies when you're doing arithmetic, right? If we were doing 7 minus 3 squared plus 1, you have to do 7 minus 3 first, and then you have to add 1. But on this, we're actually algebraically manipulating this equation here, so we can do whatever we want at any point in time. You could add 700 to both sides here if you wanted to. I mean, it wouldn't really help as far as solving the equation, but it would work. So what we're going to do, I recommend adding 13 here to both sides. And then what happens is you get 2x minus 3 squared. If you think about it, negative 13 plus 13 is nothing, so I'm just going to leave that blank. You can write plus 0 if you want. And negative 5 plus 13 would give us positive 8. And then what we can do now is we can divide by 2. And this will give us x minus 3 squared is equal to 8 divided by 2 is 4. And what we're going to do now is we are going to apply the square root on both sides. So the whole point of that is to get rid of this square here. So we apply the square root to both sides. Since we're applying the square root over here on the right, don't forget to put that plus or minus there. Everybody always forgets. Okay, so we got x minus 3 is equal to plus or minus 4. So, sorry, plus or minus the square root of 4. So that's plus or minus, not the square root of 2. It's just 2, right? The square root of 4 is 2. I see a lot of you guys writing the square root of 4 and then writing the square root of 2. The square root of 4 and the square root of 2 are not the same thing, so don't write them in the same spot if they're different. Okay? The square root of 4 is 2, so those are the same thing. So you can write it as the square root of 4, or you can write it as 2, but don't write it as the square root of 2 because it's not the same. Okay, we're going to add 3 to both sides. And so what we're left with here is we got two options, either positive 2 plus 3 or negative 2 plus 3. Those are our two solutions. So that would be 5. This one would be 1. So our final answer here is x is either 1 or 5. And again, if you're not sure if you did it correctly, go plug it in. See, if you plug a 5 in here, let's think about this. If we plug this 5 in for x, you'd have 5 minus 3, which is 2. If you square that, you have to do exponents before you do multiplication, right? So if you have 2 squared, that's 4. 2 times 4 would give you 8. And if you had 8 minus 13, that would give you negative 5. So that works. All right, let's move on to number 12 here. 12 says, what are the solutions for x squared minus 5x minus 24? Okay, this is really nice because it's multiple choice. Why do I say that? Well, if you are feeling a little lazy, you can actually, instead of solving this, you can just plug in these numbers and see if they work. So like you could theoretically try negative 8 and see if it works. If it works and negative 3 also works, then this would be your answer right here. Just a thought if you're running a little short on time. I think solving this is pretty easy. I'm just going to solve by factoring relatively quickly here. So I think that's factors. Let's see. I'm looking for two numbers that multiply to make 24 that add to make 5. Technically negative 5. So what are the factors of 24? You got 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, no, 6 we already got, 7, 8 we already got, 9, no, 10, no, 11 doesn't go into 24, 12 we already have, and we're halfway, so we don't need to bother going any higher. Let's see, what would get us to 5 here out of these combos? It looks like 8 and 3 is our best bet, right? So if you pick 8 and 3, and let's see, you would need to make the 8 negative, right? Oh, let's do that in green. You'd have to do negative 8 and positive 3. That would give you negative 5 if you add those together. Okay, so, all right. Now, a lot of you made a mistake on this one. You factored it, and you're like, sweet, the answers are negative 8 and positive 3. But be careful. Negative 8 doesn't work. If you think about this. If you plug in negative 8 here for x, right? I'm just putting in negative 8 where the x's go. Do you actually get 0 here? You're supposed to get 0, right? Like, do you actually get 0? No, you get negative 16 times negative 5, which is not even close to 0, right? So be careful here. You just want to think through what number for x, if I plug it in, would actually give me 0. And the quickest way to figure these out, right, is to just take these, x minus 8, and set the whole thing equal to 0. Take x plus 3, set the whole thing equal to 0. You get to see pretty quickly that x would need to be 8 here, or x would need to be negative 3 in this case. So 8 and negative 3 would actually be option choice B. So that's number 12. Okay, number 13. What are the solutions for the equation? So you've got, let's see, you've got a quadratic over here, and you've got a quadratic over here, and they want to know what the solutions are. Again, you got a lot of options here. You can solve these. You could solve this maybe by factoring. I don't know. You could maybe complete the square on this. You could do the quadratic formula. But whatever you do, if you do want to solve this, you would want to get everything over onto one side. So if it was me, I would probably get rid of all this stuff. And in order to get rid of all this stuff, what would we have to do? We would have to add x squared to both sides. So I would add x squared to both sides. You would need to subtract 2x from both sides. And you would need to subtract 3 from both sides, actually. So if you do that, what would you get? I'm going to take this left side over here. Obviously, the right side's 0. If you have 2x squared plus x squared, that would give you 3x squared. If you have negative 4x minus 2x, that would give you negative 6x. And then if you have 3 minus 3, that would give you 0. So I'm not going to bother writing that in there. So on this one, what you've got is 3x squared minus 6x is equal to 0. And the question is, what numbers for x, if I plug them in, would actually make that equation true? This equation is actually saying the same thing as this equation. We've just manipulated it so that it looks a little different. But any solution in here would also work in here. Okay, so what you can do is maybe you can plug in some numbers here, like see if 0 and 3 work. I believe 0 works, right? So if you plug in 0, 3 times 0 squared minus 6 times 0, that would give you 0. If you try to plug in a 3, you'd have 3 times 3 squared is 9, so you'd get 27 minus 6 times 3 would be 18. So 27 minus 18 doesn't work. So A is out. I'm going to actually show you, you can factor this. Actually, a lot of people don't realize that you can factor this. What you can do is you can pull, let's see, what's the largest thing that we could pull out of both of these? So what's the GCF here? We can get a 3, right, out of 3 and 6, and we can also get an x out of both terms. So if you think about this, if we divide each one of these by 3x, what would we have? What would we have left after we do that? So that first term would be just x, and then the second term would be minus 2. Because basically those x's will cancel, and then 6 divided by 3 is 2. These 3's will cancel here, and then you'll have x squared divided by x, which just gives you this 1x here. So what you've got here is essentially 3x times x minus 2 is equal to 0. And so what you can do, again, you're looking for numbers for x that make this true. Well, why don't you just take the factors, which are 3x and x minus 2, and just set each factor equal to 0, like we always do. And when you do this, and you solve for x, so if we solve for x here on this one, you can divide by 3 on both sides. Don't freak out. You can do 0 divided by 3. If you don't believe me, put it in your calculator. 0 divided by 3 is just 0. And then over here, if you add 2 to both sides, you get that x has to be 2. So these are our two solutions here. So 2 and 0 would be our two solutions here. So 0 and 2. There you go. All right, and then number 14, which I thought was a funny problem. Many of you did not find it as funny as I did. So 14 said, promise, Mr. Thiesing, that you will never say that x plus 4 squared is equal to x squared plus 16. So hopefully on this you wrote, I promise. Although one person out of all my classes actually wrote x squared plus 16 down here, and I about like burned the paper. I was like, what? You just promised. You said you would not do that. So what was I looking for here? So this says write out what x plus 4 squared is actually equal to when simplified, which is basically just saying, hey, actually go ahead and multiply this. It's kind of like asking, hey, like if you had 9 squared, what is 9 squared? It's like, well, it's 81, right? So it's the same idea here, except you have x's. So you're going to get x's in the answer. You're not just going to get a number here. But basically the idea was, hey, go ahead and take x plus 4 and multiply it by itself. That's what it means to square something, right? So you got x plus 4 times itself. And if you do this, remember, you've got to actually go through and do x times x, and then you have to do x times 4, then you have to do 4 times x, and then you have to do 4 times 4, right? There's no like cutting corners here. So when you do x times x, you get x squared. When you do x times 4, you get 4x there in the black. When you do 4 times x, you get 4x in the blue. And then when you do 4 times 4, you get 16. So do you get x squared plus 16 when you actually square this? Yeah, you get x squared plus 16, but you also pick up this 8x here in the middle. So just make sure when you do that, when you see something like that, don't just say, oh, x squared plus 16. Actually multiply it out, and you'll see that there's an extra 8x in there. Okay? Don't forget that. All right. Last page here. So for number 16 to 21, it wants you to match the letter of the expression on the right. So these, that is equivalent to the expression on the left. So typically what I recommend on these is first check and make sure they have the same number. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So there's 6 expressions over here, 6 expressions over here. Presumably, I'm going to assume, although be careful when you do this, I'm going to assume that there must be, like each one of these probably matches up with each one of these. But there are some cases where, like you get multiple answers over here that match up with the same thing over here. So just be careful when you get questions like this, like on the OST or on the, if you ever take the ACT or the SAT for college admission, just make sure that that does happen sometimes. Okay, so probably the most logical thing to do here is to just take each expression over here and actually multiply it out and see what it is, and then just match it up. Some people will actually take the expressions here and look for the expression over here that matches with them. I just feel like that'll take a lot longer. So let's actually go ahead and just multiply this out here. So if we do this, you would get x squared plus 2x minus 1x minus 2. And when you do that, what is that actually? So that's x squared plus 1x minus 2, right? So if you have 2x minus 1x, that gives you plus 1x. So if we come over here, we're looking for x squared plus x minus 2. And it looks like that is 18. So that one would be right there. So that's A. What would x minus 5 times itself be? That would be x minus 5 times x minus 5, which is really what? X squared minus 5x minus 5x plus 25, which is really what? X squared minus 10x plus 25. So x squared minus 10x plus 25, looks like that is 21 down there. So that's B. How about C here? So C is x plus 5 times x minus 5. If you know difference of squares, you know that that will be x squared minus 25. But let's actually multiply it out so you see why. So this would be x squared minus 5x plus 5x minus 25. And when you do that, you'll notice that, hey, these two things cancel each other out. So you're just left with x squared minus 25. So that would be... that means this is going to be C right there. Why am I red here? I don't want that. Okay. How about D here? So D, we've got x squared minus 2x plus 1x minus 2. And when you do that, what are you going to get there in the middle on these two? You're going to get negative 1x. So basically what you've got is x squared minus 1x minus 2. Which is 16 over here. So that's going to be D. How about x plus 5 squared there for E? So if you do x plus 5 times itself, don't write x squared plus 25. You give Mr. T a heart attack. What would this be? This would be x squared plus 5x plus 5x plus 25. So what is that actually? That's x squared plus 10x. Plus 25. So that would be 17 there. So that's E. I'm assuming 20 matches with F, but it's always nice to check. So what would this be? This would be x squared minus x plus 1, which is really x squared minus 2x plus 1. And look at that. Yeah, that matches. So that'll be F there. Okay, cool. So that's that one. How about 22 here? So 22 says, what is the picture to the right demonstrating? So if you look over to the right, what they've done is they've actually done a completing the square diagram, except this one's a little different. So instead of x's here, they actually put a 2x here. So it looks like they've got 2x times 2x, which would give you 4x squared here. And then it looks like they're adding 3 to complete the square here. So that gives you, when you do 2x times 3, you get 6x there. And then same thing here. When you do 2x times 3, you get 6x there. And it looks like we're going to have to add 9 to complete the square here. Okay. All right, so what is this demonstrating? Let's just look at the answer choices here. and see what we've got. So this is saying, this first one is saying if you do 2x plus 3 times 2x plus 3, you get 4x squared plus 12x plus 9. So if we come over and look at this, if you have this right here, this is 2x plus 3. This is 2x plus 3. And when you actually multiply those together, what do you get? Well, you get 4x squared plus 6x plus 6x plus 9, which is actually 4x squared plus 12x plus 9. So it looks to me like, yeah, that's actually, that first Roman numeral there, that's actually accurate. The only difference between the first Roman numeral and the second Roman numeral is that instead of doing 2x plus 3 times 2x plus 3, they wrote 2x plus 3 squared, which is actually literally the same thing as this, right? What does it mean to square something? It means you multiply it by itself. So if you take 2x plus 3 and multiply it by itself, which is what we have here, we literally have 2x plus 3 squared. That's what it means to square something. You get the same thing. So this one's legit. That works. What about this one? So this is saying 2x times 3 times 2x times 3 is equal to 4x squared plus 6x. So, this just doesn't really make any sense to me. So 2x times 3, that would be kind of like if you took this 2x times this 3, you would get 6x. So this one doesn't really make any sense to me. So I would say this one's out. So it looks like to me 1 and 2 are the only ones that actually make sense here. So we'll say 1 and 2 there. Okay. All right, let's keep moving here. So number 23 says, for number 22, why is the area of the rectangle 6x instead of 3x? And I got a lot of different answers on this. This is kind of fascinating. A lot of people said, look, you've got 4x squared plus 12x plus 9, and 6x happens to be half of 12x, right? Because we said, like when we completed the square, hey, you got to do half of, like that 12 there would be, half of that would be 6. So it makes sense to do 6x here and 6x here, which wasn't really what I was actually going for with this question. What I was going for with this question was this idea that normally when we did these, you remember like when we did these, I'll just draw one real quick. If we had like x, and then if we had like a 6 here, or not a 6, let's do a 3 here. If we had a 3 here, this was normally 3x. And then if there was a 3 here, this was also 3x. And then this would be 9 up on the top, right? Like you'd add 9. The question was, why on this square here is there a 6x instead of a 3x, right? That's what I was getting at here with this question. And the answer is because on this square, you're doing x times 3. But on this square, you're actually doing 2x. This is 2x right here times 3. That's why you get the 6x there. Okay, so that's what I was looking for. You could basically say here, you could say because 2x times 3 is 6x. That's basically what I was looking for on that one. Okay. All right, and then now we move on to the last problem here, the challenge problem. Write a quadratic function. I had people hilariously write a linear function that happened to go through both points. And I thought, maybe I should give you like a point or something. So, because you did find a function that went through those 2 points, but they want a quadratic function that goes through those 2 points. So let's actually mark those points first. That's probably what I would do first. So 2, 3 would be here. And then 3, 5 would be there. So I was thinking that here's how I would solve this one. I would first realize that it looks to me like we're probably going to have a parabola that looks kind of like this, that goes up like this. I guess technically you could have a parabola that opens down that would still work here. But let's assume that we're opening up like that. And I'm just going to, just for the sake of making this problem easier, I'm just going to assume that this red dot here at 2, 3 is the vertex of the parabola. So it's the lowest point of the parabola. That means that the parabola is nice and symmetric, which means that if there's a point here at 3, 5, that there's also a point here at 1, 5. And I'm just going to assume that the parabola opens up like this. Okay? So immediately that tells me that the vertex is right here at 2, 3. So if you like vertex form, which I do, what you can do is you can say y equals, we're going to put some number here, x minus some number squared plus some number. We know instantly that the number that goes here is 2 and the number that goes here is 3 because that's what vertex form does for us, right? It tells us where the vertex is. It tells us the vertex happens to be at 2, 3. The only issue here is making sure that whatever number I happen to put in here where this little blue number symbol is, we just need to make sure that when I actually plug in 2 for x, that I get 3 for y. Okay? And when I plug in 3 for x, I actually get 5 for y. So let's check this out. If I plug in 2 right now for x, would I actually get 3 for y? Let's think about this. If we plug a 2 in here, you get 2 minus 2 would give you 0. 0 squared is 0 times a number is going to be 0 plus 3. So you're going to get 0 plus 3, which would give you 3. So that's good. So that one works. So this one works. How about the other one here? If I plug in 3 for x, do I actually get 5 for y? Maybe I should write this out. So if I plug in 3 for x, so you got 3 minus 2 squared plus 3. What do we get here? So we get 1 squared plus 3. So that's 4. So we want to get 5 when we do this, when we plug in 3 for x. So I can't change to 3, but I could feasibly put a number out in this box right here that would make this equal 5, right? So like what number would I have to put out in this box right here to make this whole thing equal 5? Well, if this is 3, we're going to have to add 2 here to 3, right, to get 5. So what if we put a 2 right there in that box? So if you plug a 2 in the box here, that seems like that will fix the problem here. So I'm not saying this is the only answer, but if I was answering this, this would be my answer.